In this lesson, we're going to examine the idea of an arithmetic sequence. An arithmetic sequence is defined as a pattern of numbers that have a constant difference between the terms. So these red things over here, take a look at them. Okay. I'm going from 3 to 10 to 17 to 24. I'm going up 7 every time. There's a pattern. It's constant. It never changes. Look at the next one, 12, 8, 4, 0. I'm going down 4 each time. Again, it's constant. Never changes. Those would be considered arithmetic sequences. The blue ones, on the other hand, while they follow a pattern, are not doing a constant pattern. 40, 20, 10, 5, it went down by 20, and then down by 10, and then down by 5, and then down by so on and so on. It's cutting in half each time. The rate is changing as we go. That means it's not arithmetic. We try the next one. I go from 1 to 2 to 4 to 7. I went up 1, and then went up 2, and then went up 3. Again, it's a pattern, but it's not a constant difference. And that's our key. A constant difference is the definition of an arithmetic sequence. It has to be the exact same number every single time. We often want to make equations that can represent these patterns. We'll create a function. We're going to call this the nth term or general term. Okay, but we can think of that as our function, our idea, or an equation. Just the words will come across are nth or general. Okay. Generally, they take the form given here. Tn equals a plus n minus 1 times d. Okay, that's our function form. What we're going to do is we're going to fill some parts and pieces in. Tn is our term value. It's the function. It's like your fx, f at 1, f at 2. But in this case, it's going to be t1, t2. Okay, the term value. A is our first term. N is the number of terms that we have. And d is our common difference. Notice here that we are multiplying this piece times d. Okay, so we're going to try one here. So we're going to state the general term. That means make an equation for each arithmetic sequence, and then we're going to find T12. T12 stands for term 12, or if you will, you can think of this as F at 12, the 12th thing. What's happening when n is 12? So what do we need to know? Well, we need to know our first term. It's 2. We need to know our constant difference. We're going up by 3 each time. We don't know how many terms there are. That's what this dot, dot, dot means. It keeps on going. So to find any term, we'll say Tn. Tn, remember, is our function idea. And I could find any term equals a plus, in brackets, n minus 1 times d. And we often simplify this. We do that by expanding. So 3n minus 3, and then collecting. And there's my equation for any term. For instance, if I want to find the first term, which I already know, well, obviously we have it, but I could say term number 1 would be 3 times 1 minus 1, or 2. Term 2 would be 3 times 2 minus 1, or 5. Now we already know those ones. We were given them in the question. We actually have to find term number 12. I can find any term in the sequence using this equation now. T12 will be 3 times 12 minus 1. Just like with function notation, wherever I see an n, I'm going to replace it with a 12. So the 12th term is 35. And that's it. Okay. And I get you to try the second one. So pause it, give it a try. What do we know? A is 15. Constant different, we're going down 5 each time. So Tn equals a plus n minus 1 times negative 5. We'll expand our brackets. We'll collect like terms. And the order is not really important. Over here I put the n first, now I put the n last. It doesn't make a difference. Okay, that's your general term. We want to find term number 12. So term 12 would be 20 minus 5 times 12, or in other words, negative 40. And we got one more. This one's a little bit messy. Not all our arithmetic sequences are nice pretty ones like we've been looking at. We can come across fractions. They're still considered arithmetic sequences as long as they follow a constant difference. So if we examine this one, our a value is 1. Our difference is It's kind of hard to tell if you look at the first two things. But if you look at the next two things, you can see that they go up by 2/3. And the next one, does it also go by 2/3? Well, again, it's hard to tell. But if you made these things into common denominators, you actually have 3/3, 5/3, 7/3, 9/3. We just don't usually write 3/3 as that. We write it as 1. And this one has 3. Okay. But the nice thing about arithmetic sequences is the difference is constant. So you don't have to know the first and second. You can know the second and third, or third and fourth, or 10th and 11th. As long as you know two consecutive terms, you can always figure out their difference. So Tn equals A plus n minus 1 times D. We'll expand, and then we'll collect, and we get 2/3 n minus 1/3. If I want to find term 12, we can do that. We'll plug the 12 in for n, and we'll do a quick calculation here. And I get, what's that, 24, 23 thirds. Actually, no, sorry, that's a plus 1/3. My fault, 25 thirds. Okay, there's our definition, our equation, how to find terms. Let's do some problem solving. So an arithmetic sequence is defined by this expression, Tn equals 12 plus 4n. Find the first 5 terms of the sequence. Okay, we can do that. Term number 1 would be 12 plus 4 times 1. In other words, 16. Term 2 would be 12 plus 4 times 2. 20. Term 3. 12 plus 4 times 3. Now I can keep doing this, but shouldn't an arithmetic sequence follow a pattern? If I look at term 2 and term 3, they go up by 4. Well, that means the next one should also go up by 4. And the next one after that should also go up by 4. It has to follow a pattern to be an arithmetic sequence. For part B, finding term 47, well, now I don't want to keep adding 4 because that's way down the line. So here's where that equation comes in handy again. 12 plus 4 times 47 comes out to 200. Okay, I don't want to write them all out. I can use my equation. Okay, the sequence contains the number 300. Which term is it? So now I know my term value. I can put it in for the t. I want to know t what is 300. I can do that by using my equation again. I just got to solve for n this time. So 300 minus 12 equals 4n. 288 equals 4n. N is 72. And therefore, if you really wanted to write this way, you could say that term 72 comes out to 300. Okay. The last term, 864. How many terms are in this sequence? Well, that's basically the same question all over again, right? It's asking us what term number is the last term. I can solve this. Do the exact same thing we just did. And divide by 4n again, or divide by 4 again, and we should get 213. And there's 213 terms in this, because I know that the 213th term is 864. And we were told that was the last term. So we can problem solve a little bit. And what else can we do? So I've got a sequence here for you. Can you find the equation for the nth term? Nth term is another way of saying the general term. We can do that. Tn equals our first term plus n minus 1 times the difference of 6. Expand and simplify. I've got 6n minus 1. Okay, 42nd term, basics. 6 times 42 minus 1. That gives us 253. Okay, is 624 a member? Well, let's see which term that is. So 624 plus 1, 625. And what do I get for n this time? Well, if I try dividing this one, I get 104.16. Well, you can't have a decimal number of terms. You know the 104th term, know the 105th term, the fact that this comes out to a decimal tells me this is not in the sequence. It's partway between terms and number 624. It's not part of the sequence. Okay, letter D, the last number is 137. How many terms are there? Well, we've done this one before. Let's solve this one. This one has to be part of the sequence, right? Because it's telling us it's in the sequence. We just have to solve for which member it is. And if we do that, we get 23. Okay, so there's 23 terms in that sequence. And a word problem for us. We have Jeans Inc. When they opened, they had 300 people employed. Each year, the number of employees has increased by 15. How many employees will there be in the 9th year? In other words, what's term number 9 of this pattern? It's a pattern because it's going up by the same amount each time. So if I make myself a general equation, start with 300. We're going to go up by 15 each year. We'll get 300 plus 15n minus 1500. Or in other words, 15n plus 285. So if I want to find term 9, 15 times 9 plus 285. Into my calculator, and I got 420. Okay. In what year will the company employ more than 500 people? So when do I hit 500? Well, I have to determine the sequence. Or maybe we'll have to figure that out, I guess. So we can solve this. What's that? 215 equals 15n. So we divide by 15 and we get 14.3. Okay, so we have to interpret now. So 14.3 is between terms. It's not the 14th term, it's not the 15th term. We want to know when will they employ more than 500 people. Well, in the 14th year, we haven't quite reached 500 people yet. So we actually have to round this up to the next term. So in the 15th year, a company is 500 people. With the 14th year, we wouldn't have got up there yet. We'd be at 285, right? We're going to assume they only hire at this beginning of each year. If they could hire a couple here, a couple there, it's a totally different question. It's not really an arithmetic sequence anymore. But if they only hit the hire the 15 at the beginning of the year, we have to wait to the next year to get to the 500. Okay, last question, last problem solving. Okay, find the general term for an arithmetic sequence if the second term is 18 and the 21st term is negative 20. So they're giving us non-consecutive terms. What can we do with that? What do we know? We know that term number 2 is 18. We know that term number 21 is negative 20. That's what we know. What can I do to figure out the general term? I need the initial value, the starting point, and I have to figure out how much it changes by. So there's two ways we can attack this. We can do a mathematical way and we can use a common sense way. I'll show you both. Let's do the math way first. If we take our equation, Cn equals a plus n minus 1d, and we fill some stuff in, we know 18 equals a plus n is 2, and I can set up an equation, a plus d. I can do the exact same thing with the other equation. I don't know a, I know n is 21, I don't know d, but I can simplify this and say 20d. Now I've got myself two equations with two variables. We can solve this. If I take this equation and put it underneath the other one, 18 equals a plus d, I can use elimination. My a's are the same, they have the same sign, so I'm going to subtract them. And that would give us negative 36 equals, negative 38 equals 19d. Or in other words, d is negative 2. Now if I know d is negative 2, I can go back to this equation over here and say, well, 18 equals a plus negative 2. Or in other words, 18 plus 2 equals a. is 20. Hey, if I got A and D, I got an equation. I can make that equation really quick. So that's the math way of figuring out A and D. Common sense way. Okay. 19 terms. That's the difference between the second term and the 21st term. And we've gone down from 18 to negative 20. So haven't we gone down 38? So what is negative 38 divided by 19? Well, that's my difference. Negative 2. It's a faster way of getting the same thing as we had down here. And once I know I've gone down 2 each time, could I not really quickly think, well, if the second term is 18, I go down 2 each time, the first term has to be 20, right? That doesn't, just by using some common sense. Either way, I get A is 20 and D is negative 2. So I can make my equation. A is 20 and D is negative 2, and expand and collect. And there is the general equation. Now, I'm not really picky for this stuff if you want to use common sense and figure out all the difference. I can calculate the difference by just dividing and thinking about what's happened, or I can use my mathematical formula way and use elimination. They both work just the same, just more thinking over one than the other. Okay, homework, some things to try. Some of the questions in the book talk about something called recursive. Don't worry about that. Just find the idea of a general term, the equation for me. That's all we need for this.